this one here, this one here, this one here, this one here. I'll go ahead and remove this one and the other one too. Maybe I don't need to have it sit around that long just to get this tied in here. Just a little quick thing. Okay, that looks good. It looks like it's going to hold. Okay, yeah, that's going to definitely hold. And you know, one side's more round than the other because of the you know, the tube was kind of crimped on one side as I was winding it, but it should be fine. It shouldn't be too big of a deal. Let's see here. So I removed some of these things, so now I'm going to put them back onto the other one. So let's go ahead and measure the inductance of this one again. Okay, so over here we've got an inductance of 0.40 or 0.39 thereabouts of that would be millihenries. Here we're measuring 384 or 385 microhenries. Let's go ahead and grab the second coil. So over here, we've got 394 or 393 microhenries of inductance. 393, 392. Anyways, so, okay. So basically within the same ballpark. How many turns does this have? So the other one had something like 25 turns. Let's go ahead and check this one out and see what we got. So I'm going to count it by using these nylon clamps in order to divide them. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then another one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so this one also has 25 turns of conductors. Let me go ahead and separate these some more. So basically 5 conductors for each of these clips over here. See if you can verify that. Okay, so that's about 25 turns there. So all in all, I got 50 turns, a bit more turns than I was calculating, but that calculation was based upon the old geometry that was a little bit bigger. Now, one of the things I want to do right after this is, let's go ahead and remove this. So again, this is the second coil I made. You might be able to tell that from the ends of the wires here. Alright, so pretty much done with this one. Let's go ahead and let's connect these coils together in order to have a good idea exactly what happens when we put these coils together. But yeah, I have to measure the resistance of this coil versus the second one. So let's just go ahead and do that. Let me see here. This needs to have a good connection. Okay, there we go. So 0.167 ohms, or 167 milliohms. Okay. So the same deal as the other. Let's go ahead and connect the other thing. So this is the second coil. The first coil is over here. So this one, 0.166 ohms or 166 milliohms. It's pretty much the same deal. And it kind of makes sense because the other coil is a little bit longer, because you see one of the extra wires here. It's a little bit longer. You can see this extra wire on this edge. So that's probably where that extra 1,000th of an ohm comes from. But yeah, they're 25 turns each. So that will be enough of that for now. So now that I've put these together, actually I want to clip these wires together in order to make a measurement. Which measurement should that be? We need some alligator clips. Additional alligator clips for making a connection somewhere. Or what exactly? Now what I need to do, really, is attach some leads to these wires here, or some kind of metallic contacts. So I know how to do that. I've got these crimp connectors here. What else? Got this tool that I can use for making the crimp connections, and of course I need to make sure it's sanded well. So we're going to make sure, just for extra benefit, make sure it's sanded very well. So first of all, we want to straighten this out. So which tool will we use? I can just use my gloves and kind of do this with force. Let's go ahead and so this thing needs to be opened. Let's go ahead and open this one there. And make cuts in here, pop it open. It's over here too. So these ringing terminals can be crimped onto this here. So you can see we have a contact way inside. As you can see in there. Yeah. It's got maybe another hour of sun before it sets. See how many hours we got on the video. 6 hours on the video. So, and this thing over here. And the rest are just the same. Go ahead and do some more sanding on here, and then we are going to crimp the connection. I'm going to do it a little bit closer to this thing. Go ahead and trim this part off. Start fresh on here. And we're going to go ahead and sand this. So, put our gloves on for this one. Oops. Alright. A second. I realized that. Let's see here. To make sure that I technically don't need to sand this. Let's go ahead and ensure we got a good connection here. Okay, so I want to make sure that the end of the wire is meeting up with the metal ring here. So this should work. Let's go ahead and find out if it does. But first of all, let's make sure that we have a solid connection here. So just the way to do that is to connect these ends again. So yep, we've got a connection. Alright, let's go ahead and do this. So crimp this side over here. And how do we do this? Insulation, insulated, non-insulated. So on this thing here, we've got these settings for here for the crimp connections. So I'll be able to crimp this very well onto here. Okay. So inside here, we've got this. We've crimped it on. So hopefully this was successful. So let's go ahead and test to see if we have a connection. Alright, so good. We have a connection for our inductance, which means there's current flowing through the wire, and the sensors and the device then calculate the inductance based upon how quickly the current rises and falls. So there it is. Okay. Pretty straightforward. And we want to do the same thing to the other side. So go ahead and do the same process on the other side. Over here. So I just want to make sure that this is the right length. And we know that this is sticking out a little bit more than we need it to. So what we can do is stretch this out over here. Go ahead and straighten this one out here. So let's go ahead and cut this part here until we're something like the length of this sticking out over here. Let's go ahead and cut that. Let's just try this one right now. Let's make it a little bit shorter. So, let's go ahead and crimp this one on. Oh, that's real good. Nice. Okay. So let's hope, see, that's better. Okay. Do not have a connection. That's not good. And so, what is the reason? Oh, the reason might be I didn't actually sand the other side. That's stupid. Right, that's the reason. Okay. Let's go ahead and sand the other side. Alright. Okay, now after that was done, first of all, let's see if it's not the other crimp connection that's the issue. Okay, so we have a reading here. Okay, so that means that connection's good. Now we need to crimp this other side on. Alright. yet. Okay, so now we've got a connection on this coil based on a crimp connection here. So now we want to do the same thing to the other coil. Let's go ahead and see if this is connected. That was already sanded, so... Okay, so we got a connection. So now what we want to do is trim this other wire here. And do the same thing. Alright, so got that. And we'll sand it. next? This needs to be crimped more. I think if I did it right, I wouldn't need to sand it. I just noticed inside here, if I crimp it in the right place, these things here, the way it bends, should crimp into the copper, like that. I didn't do that for all of them, like for the other two, but I still have a connection, so that should be fine. Let's go ahead and test this again. Next time around. Okay. So we better have connection here. Let's see if this is true. Okay, we got a connection on both of these. We've got 383 millihenries of inductance over here. We got 376. $374 millihenries of inductance. 375 microhenries of inductance. 375 micro. And here we have 379 microhenries. 379 microhenries. And this is 376 microhenries. So pretty much the same deal. So 375 microhenries here. Now which one was the old one? Which one's the new one? I forgot. This is the old one here. This is less neat than the other. 376 microhenries. 381 microhenries. Okay. So one thing I want to do now is connect these coils together, essentially in a series type of mode here. So go ahead and connect these together. So go ahead and connect those, and over here it'll be a little different. Add this one over here, and it comes like that. So we're doing that. I have sometimes screws. Which ones do I need to use? These ones are not the right size, or are they? I think these ones work. Yeah, this would work. Okay. So, scissors. So I got these machine screws over here. So this should work. Let's go ahead and put these in here. Let's take this out of here. So 12 pieces here. So I gotta keep in mind this is 12 pieces. Yeah, we're gonna have enough. So that goes in there. Maybe like this. Perfecto. Right. So, what we're going to do, we're going to measure the inductance of these two coils connected together, but side by side, and then we're going to move it around and stuff. Okay, so let's go ahead and measure the inductance of these combined, side by side. Okay, so together, side by side, the inductance is 714 microhenries. Okay, now what we're going to do, we're going to take this coil and put it on top of the other. First, we're going to see to it that we've got the things here. So, now basically, I have, in this configuration, the coils are in the same polarity. Okay? So with them in parallel, now I see my inductance has increased to 1.180 or 1.179 millihenries of inductance. And so if I were to then move this away, now we see as I move it away, my inductance fell over here. Now it's 0.689, and if I move it further away, now we got 0.734, 0.745, okay, so I'm going to move this one away from that. Say if I lift it up, let's go ahead and click this one here. So 0.712, so on. Probably a good way to address this issue. I have another table because the C-clamps might affect the inductance value. So I've got another surface, and I'll show you the metal that's underneath it. It's not that much. So over here, you've got this metal thing for the wood, but it's not that much. And here's how thick the wood is, so it's not really going to affect the thing very much. Let me go ahead and pull this out here. And so now we're going to go ahead and bring this over, like so. And then you see here, right, so we've got 0.718 millihenries in this configuration, and as I move the coils apart, 0.748, 0.54, so 0.754. It's going down. It's going down, going down, going down, going down, going down, going down, going down. Now it's going really down. Going down, going down, and so on. This. So the reason why the mutual inductance is dropped is because both of these coils are rotating the same direction. Essentially, the current, as you can see in this connection here, it's going, say, clockwise, and it goes across this bridge and continues to go clockwise on this other side. I've got counter-moving currents in this loop and in the other loop. And so, since these fields cancel, it reduces the amount of flux linkage, overall net flux linkage per current, and so we see a different value. Now, as I move these coils apart, some of the flux lines that would have canceled between the loops is no longer canceled. Okay, so this is one particular configuration. Now, if I can put one set of loops above the other, which I'll show you right now. So I'll go ahead and kink this out here. So this needs to stay on. Okay, so I'm going to put this one up here, like so, on top. And now you see the value is greater because now we got greater amount of flux linkage per amount of current. And so we have a greater inductance. So 1.180 0.92 millihenries or 1,192 microhenries. Okay, so what happens if I decide to turn this upside down? I can do that quite easily. And turn this upside down, you'll see a big drop in the inductance value once I do this. So I'm going to go ahead and just turn this one upside down. And now I'm going to crimp these together the same way I had it before. Now we have the coils. They're basically, the currents are now in opposition, so there's a significant reduction in the magnetic flux linkage per current, and so therefore a lesser inductance. And we see we have 0.316 millihenries of inductance. 0.316. That's 316 microhenries of inductance. So what happens if I decide to bring this coil ahead of this one here? Now, let's go ahead and do that. So when I do this, you'll see now my inductance value has jumped up, because when these coils were in opposition on top of each other, one on top of the other, you had one value for it. But now, because they're side by side, they actually somewhat reinforce each other's magnetic fields through a magnetic field that goes around these conductors. In this case, the currents in these sides are going in the same direction. Now, the multimeter, this LC multimeter, inductance capacitance multimeter, it's actually oscillating the current at a frequency, and then from that frequency, and then it calculates the inductance value based on that formula for the basically because if you have an inductance and a frequency for a waveform, it's going to affect your inductive reactance, and because the inductive reactance is part of the electrical impedance, then it affects how much current is going through for any given amount of voltage. So it does the calculations that you can find online for the inductive reactance, and it will show just how they're related. But we have this reading here, 0.883 millihenries of inductance, or so 883 or 882 microhenries of inductance. So let me go ahead and put it over. Again, because now the coils are over, they're canceling their magnetic fields with the currents going in opposite directions, as you can tell by just examining these ends here on that end, like so. So 0.336 millihenries, or 336 microhenries in this case. Of course, if I shift it, it affects the value, and so on. So now, if I compress it, I might even get a lower value through the cancellation. But that depends, because then I could also be compressing the windings within. And so, actually, as it turns out, I'm reducing it even more, 0.283 microhenries of inductance. 0.283 millihenries, so 283, 284, 288, whatever. So let me go ahead and press it some more. Okay, so I pressed it even more, and now you can tell, we got significant cancellation here. Let's try to line it up even more. Okay, now we lined it up even more, 0.27 millihenries, or 0.271 micro, so here we have, it's changing all the time, 273 microhenries of inductance, okay? Now, again, if I decide to turn this upside down, so basically, let's say we connect this the other way as before. let's do this. Okay, so again, they're stacked on top of each other. Got 1.196 millihenries. It's 1,195 microhenries. It's, you know, trying to settle on the value. So let's go ahead and see what this shows. 1.21 millihenries at that setting. 1.2 millihenries. This setting, 1.195 or 1.195 millihenries, so 1,195 microhenries. Okay, again, if I move this away, there's less reinforcement of the magnetic fields. Moving them away, the mutual inductance is dropped, as you can see there, 773 microhenries. And bringing it back down over here, you see it jumped up. Now, bringing it to the side, you actually see it has reduced significantly. And we can reduce that value even more. So 0.661 millihenries, or 661 or 662 microhenries. Okay, so again, this gives us amount of magnetic flux linkage per current in these loops. So that should be it for that. So now that we did that, so two avenues I could do. The first avenue is I could start building the magnets. That's one thing I could do. Or I could start, you know, finishing these coils here. And what I'll do, since essentially, let's see here, I'll do the magnets first. So that way you can have a good idea of what happens when I put the magnet into the loop and I pull it out. You should see it affects the induced voltage in the circuit, and we should be able to pick that up. Now when we fold it into the show coil, we won't unfold it to see what it would have been with the coil straight. So we're gonna build a magnet stack. Let's see how many hours I got. So 3 hours is plenty of time. I think, you know, in about an hour or an hour and a half, I'll have the magnet stack completed. So I'll have that, and I'll test how that affects the magnetic induction into each of these coils and them simultaneously, and all that jazz. And once I've done that, I'll fold them into the show coil shape. If it turns out that I don't have enough time within the 10-hour allocation that I have on my card, what am I going to do? Because I have right now 3 hours and 17 minutes left on the card, so it gives me a strict limitation of how much I can record and everything, and at any given constant interval of time. So, but that should be enough time to build a magnet. I'm sure even an hour should be enough. And then the critical thing is to get the stuff into the hooks for the show drive. Let's go ahead and zoom out. Okay. All right, so let's go ahead and, all right, it's a little bit of that sunset. barely with the sunset. Okay. Let's take a little view of the room. And if you're wondering about that noise in the background, that's I think it would be the diesel generators for the for the coolers, because they are freezing the ground somewhere beneath our feet for the linkage tunnels, or the emergency passage tunnels for the light rail that they're building underneath this building. It's going to be from, say, U District over there, somewhere south, and then they're going to build another station over at Roosevelt, I think, somewhere north, over that way. So anyway, need to drink some water. Got a couple of days on my lease left. I gotta leave pretty soon. Trying to maximize my utility here with. I mean, basically this place costs the equivalent of $30 a day to live here. Now, if I factor in the utilities, maybe like 32, 35, whatever dollars daily. So I want to maximize what I get out of those $30 to $35 daily of expenses just to be here, because my default that I've been doing is living with parents or relatives. So this is very unique for me. I've been able to pull this off finally, being independent for 1 year. It's going to end pretty soon. Not much in the way of, say, being able to stay independent, more than a year. But I've been able to have the space necessary to not create too much friction in the household, at least for this period of time. So I'm able to do these projects without, too much going on in terms of distracting other people. So, well-insulated apartment, and everything. It's small square footage relative to the rent, but it gets the job done. No rats or anything like that. So that's good. Don't want any rat droppings and whatever, and mold and like broken holes in the wall, so it is what it is. Go to the restroom. what I'm concerned about is the coils are actually considerably thicker than I thought they would be. So the hooks I have to go into the acrylic panels are a little bit too small to handle these coils. Now, my wire bender is actually multi-size. Let me show it. Go ahead and this is actually a tubing bender, but as you can see, there's multiple sizes it can handle. So, and let me just give you an idea of the size of this. Let me show you the using a ruler. This is how large this is. So this will give you a radius, or a diameter, let's say a diameter, of here. Let's see if this is good enough for you. Yeah, you should be able to see those numbers. So measuring from, say, here, you see there's just over 1.5 inches for the inner diameter of that. And then over here, getting really close, it's just under 1.5 inches. Now, if that ruler is not good enough, I have this other ruler that I'm sure will show it a little bit better for you. So here it is. Yeah, totally. So here it is. So lining up with this inside there. And then kind of sliding it up here. And then over here. All right. It's about 1.5 inches inner curvature of that. So that's essential for curving the show coils that I'll be doing. Now see here that the diameter, did I say the radius is that's the diameter. Okay, so this is the diameter here, and we see this is something like 3/8 of an inch in a diameter. Okay, if you can see, it's a little bit better there. Yeah, there we go. Pretty okay. So that's that. So just for an example, go ahead and take this one next to there. Oh dear. Alright, so I'm going to have to go ahead and unscrew this one here. And here, got these coils. Let's go ahead and unhook this thing. Just to give you an idea, we would have this tubing bender stretched around like that, at this gap over there, and we would stick this thing over here, like so. Now, when I do that, let's say I close it, it has some issues holding it together. I might need a bigger tubing bender because this is a little bit, and as you can see, if I hold the sides well, I should be able to turn it properly. Now, I'll be clamping the tubing bender on the surface of that workbench, so I won't have that issue. And then, in doing this, I'll have the shape I need for the show drive. Again, let me show you So imagine I took this rectangular coil and I folded it into an S shape so it looks like this thing over here. So I have the curvature of this, curving it in this shape over here, like so. And I would have two of them, one slightly on top of the other. Now you see how thick this is, and just give you an idea of where this would be. Here is the crate over here. You see this bearing inside, right? So I have this panel over here, and the show coils will be folded inside. It's in such a way that will be shaped like an S. And just to give you an idea of the size of that, this is how big it is to scale. So essentially it would be here, like so, inside. Now I made the sides a little longer. I'm gonna have them an extra inch. Actually, let's see. This when I calculated on the spreadsheet on a previous video, I calculated that the total length of each of these line segments on the red is 18 inches, and the same with the blue, it's 18 inches. Now I've got 21 inches, so that gives me an extra inch and a half on each side, which is basically the size of this whole grid here, if you can see the fine lines in the grid. So they would be stretched out a little bit more. So when I have it like that, what I'll be able to do, for example, I'll be able to take the temperature of the coil by sticking it on the sides over here, and also because there's going to be a fan on the back over here. So this is going to be the fan that goes in the back of the crate. It's the blue. It's not the blue one. It's the. It's this blue one here. The third one. It's the third one. There it is. Right there. That one. So that's the one I have. So when I have this on here, with the other pane and everything, it's going to be held together simply through the pressure of the tendency of these show coils to pop out sideways. So to have a tendency to pop out sideways, it's going to be under some pressure. And that pressure will push the acrylic panels to the sides, and they're going to be constrained by the back rods and on the front rods too. So the result is it's restrained inside. So looking at this again, over there. And we'll have a magnet stack inside, and I do believe that I will be putting the magnets in the crate for display. I've got 3 hours and 2 minutes for that. So let's go ahead and let's build the show drives magnets. Now make sure I don't have any credit cards in my pockets or something, because I don't want to be erasing any information for transactions and stuff. So let's go ahead and put this here. Keep our coils nice and far away from the windows. I'm going to go ahead and put this back, because I don't need this right now. And I will need to put my glove on for this, of course. It's going to be pretty strong magnets, and I want to make sure I build this correctly. Now I said I was going to make a numbered guide for the assembly of the magnets. So let's go ahead and go through and anticipate exactly what the assembly order would be for the magnets. I'll write this down on here. Write it down with a pen. Okay. Alright, so let's get this going. We'll put this crate back here. So put this over here. Put our game pan on. So let's make our game plan. Because we don't want to damage any magnets or have it clashing or forcing against us when we try to assemble them. So we want to make sure that we put the right magnet on first at the right time in the right order. Okay? So this is upside down for you. So let me go ahead and turn this upside down for you. Okay. So basically, we've got, let's put the shaft here. Okay. So this is our shaft, and it's got these magnets here. Now this paper's to scale. So I've got my, let's go ahead and turn it this way around. I'm sure you can read numbers sideways. This should be all right for you. So there's our magnets over there. Our 3 square nuts. That's what we call it. Square nuts. So 3 square nuts go over there. It's to scale. So first of all, we want to put a magnet on the top of these square nuts. So we'll put, for example, this one here first is going to go on top of, say, these square nuts here. So these square nuts are going to have a magnet on top. So let's say we have number 1, right? So we're going to have that number 1 first over this region here on the nuts, and then we put number 2. So number 2 will actually be actually, you know what? We'll make this one number 1 here. By making this one number 1, we have this horizontal thing. This will be number 2. Okay, so we'll put a magnet over here. Over here. Let's use an object to indicate the position of our magnets. The cap of this should be fine. Okay. Alright, this should be fine. So the cap of this. Okay. So this is more or less the size of the magnet. With sans the part that I'm covering. So I've got this magnet over here, okay, that is number 1. I'm going to have it over this part here. Now, I'm going to have another magnet So we have another magnet here. It's going to go crosswise. Okay, so here's magnet number 1. It's going to go here, and magnet number 2 is going to go this way. Okay, and so basically, then we have magnet number 3, which is going to be should be this one here. So this will be magnet number 3. So after we put magnet number 1, we put magnet number 2. So after magnet number 1, we put magnet number 2. Then we put magnet number 3, because this is now bridged, okay? Now, then, after we do that, what we want is to put, we're going to slide magnet 1 over, and then insert magnet number here's going to be magnet number 4 over here. Then we have number 5. Okay. So actually what we need to do first is after number 2 over here, this is number 4. This will be number 4 here. Okay. It's 1, 2, 3, 4. So number 4 will be centered beneath number 3. So this is number 3, this is going to be number 4. So I'm going to leave it like that for then. Then number 5 will be this one down here. And then after we do number 5, actually that won't be centered, that will already be at the edge. So after number 5, it's going to be down here. So this number 5 will be centered underneath the this one here. So then we have that taken care of. So number 5 and number 6 will be centered underneath these magnets. So we need to put number 6 is going to also be centered initially over here. This is number 6. So number 5, number 6 will be centered, and then I'll push 6 over a little bit so then it can catch. This will be number 7. Okay. Okay. So number 7 is then across number 6, and then what I need is to put another magnet. Number 8 is going to be right underneath number 7. So I'm going to push 5 off center to overlap more of 4. So now magnet number 8 is going to have to go underneath 7. Now when I have that, it now of course also makes sense to then push number 6 out further here, and this will be number 9. Okay, so this is number 9 here. And so after I've had that, actually, you know what? First of all, it's not this one yet. We need to put this one first. This one's number 9. Because now that we have 8 and 6, now we can really push this 4 off center of this center. So this number 4 now goes here, and then that should take care of that problem. Okay, so then number 9's there, and then number 10 is over here. Okay, so we had 7 here already. We had 1, we had 3 over there. So next we need another thing. So I'm going to go ahead and I'm going to finish this one off over here so we can push 1 back for the insertion. Oh, no, not yet. So now we want to put number 3 here, the next one here. And this is solid over here. This would be 11. Okay, so 11, and then this would be 12. 12. 13. So now that one's on top. This would be 14. This would be 14, 15, and 16. Now, okay, so let's go do an overview of the steps for the big magnets, okay? And then the small magnets are on the side, so let's go ahead and zoom out. Okay, so we're going to put this magnet on first, and then underneath that we'll put the second one. Now, after that, we put the third on top of the second one. And then the fourth one will go underneath the second one. And then underneath the fourth one, we'll put the fifth one down there. Now, the fourth and the fifth will be centered underneath the second. That way, then what's going to happen is the fifth one, okay, actually no, the fourth and the fifth actually are not going to be centered in this way. So what happens now is we put the sixth one underneath this square nut, and then we slide it out a little bit so that the seventh is over the sixth. After that, we put another one underneath the seventh. That will be 8. Now, after that, we have a ninth over here to do. But we could have put that underneath 2. But what we want to do is we take 5 and use it to make sure that 9, because when 9 and 4 are side by side, they're pointing in the same polarity, but I don't want them to repel. So I put 5 underneath 4, but then I slide it out sideways. Let's say I centered 5. So then after I centered 5, it's a little bit offset from number 4. Then I put 9 in that little space between 5 and 2. And then of course, after that, I want to shift number 10 across. Now, right after I put 10, I want to put some brackets to hold these in place, which I will do. And then after that, number 11 goes over here. And then 1 and 3 is going to be on top of 11, and not just 2. And then 11, of course, being on top of 4 and 9. And then, after 11, there's 12 that goes on top of 7. Then 13 goes on top of 12. Then 14 goes between 12 and the 14 goes between 12 and 6. But of course it's also on top of 8 because 8's already there. Then after I put 14, I put 15 between 14 and 13. Then on top of that, I put 16. And then after that, I put the extra small magnets on the sides. Alright, oh actually I would do that right after 10. Right after I put 10 there, I put the small magnets on the sides. Alright, so let's go ahead and assemble this magnet. Right now, I've got 2 hours and 47 minutes for the assembly. Our game plan. What's the show? All right. Let's make the magnets. Now, because the magnets attract, I'm going to have to clamp this rod onto the table. So let's do that. Alright. So, let's see here. This is the rod. I want to keep it away from my face, so how about there? And then, we then want to do something else. Actually, let's go ahead and put this like this. Alright. Maybe that makes more sense. Okay. No, this way makes more sense, I think. Let's go ahead and pull this out here. I'm going to have to add some additional height here. So that way, I can slide underneath here. So I'm going to go ahead and turn this around so I can see what I'm doing here. I'm going to turn it around like this so you can see somewhat of what I'm doing. Alright. Okay. So this way, when I look at the paper, I have it a certain direction and you can see what I'm doing here. Now I need to make sure that this goes far enough. So I'm going to bring this as far as I can over here. Over like so. Now when I put more layers of magnets, I'm going to have to make sure that I'm going to have to raise up this wood by more thickness. So I'm going to have a 1/2 inch panel underneath to get that taken care of. And oops, wrong place. So these clamps will help hold this magnet. So when I try to put some magnets here, it's not going to jump up and bring the rod or shift it or any kind of weird thing. So there it is right there. It's actually like this. So let's go ahead and turn this for you. So now that we have it clamped underneath, we have this position here. So, alright, so let's get out the magnets. Let's not bust our fingers. So here's some of the plates we'll need. I'm going to bring it close to the camera so you can see them. I need this, yes. We will need our magnetic coil detector. Let's go ahead and get that battery. There's a sword that I had earlier. Oh, I got more of these. That's good. That's... more of these brackets. We'll need that ruler. More brackets. Magnetic film. Brackets. Slotted needle. Alright. So, here's my 2 Neodymium magnets. They're in their package over here. So there's their small ones and then your large ones as well. So let's go ahead and pull those out carefully. In fact, this should be in a different container. Let's go ahead you'll need to designate a space on the table, not there, right there. So it would make sense that we would keep a separate table for these magnets at a different elevation. So I know just a ticket for that. Let's go ahead and get our wooden table. And let's get this rolling. Okay. Okay, so I'm going to put this plexiglass panel on top of here for a little bit of protection. Okay. Now I'm going to put this this is going to be our first group here. Here we've got 10 of those magnets I talked about that we're going to use, and we have an additional smaller set over here. So the logical thing would be to separate the smaller set out first. Where are we going to put this? So you could separate out the smaller set, and I could put it over somewhere where we're not going to have any metal objects. So back here, I can separate this out where this windowsill is. So I'm going to go ahead and take these magnets, small magnets, pull them out like so. So I won't be using them yet. And I'll put this over here. No metal objects over there. Now I've got this set of neodymium magnets. Now, one thing I would want to do, make sure I wonder if I could use the music stand. No. Well, let's see how this works, because I want to make sure that. Let's see. Okay. So if I put plexiglass panel over the music stand, go ahead and take this mat here, drop it over there, put this bubble tape here, and then over the bubble tape I put this one, which is interestingly enough is the same size, so that's super convenient. And then take this magnet here and see if there's any drag. Okay, so it's obviously going to be preferring the screws here. Alright, so let me go ahead and put this over on the side here. See if this makes any difference. Doesn't make any much sense. Here's what I'm going to do. I'm going to pull this out here again, and let's go ahead and put the bubble tape over here, bubble over here. And I do have another plexiglass piece over here from the laser cut procedure over here. See? So I've got this plexiglass over here. All right. I'm going to go ahead and tear this out, kind of make it clear. You know what? There's no point in that. Let's go ahead and keep it with the cover on. Okay. And we're going to put this over here. So. Good idea. This actually makes sense. You know what? This might be a good idea. So what I'm going to do is okay, so I've got this magnet stack over here, and so if this thing is going to attract to anything, it's going to be towards this music stand, okay? So I'm going to go ahead and put this stuff out of the way in a different place. Over here is a good idea. Okay, so there is our magnets over here. Okay, go ahead and have it like this. So these are just some examples of the plates that I'll be using later. And I think I'll open them maybe after I get this set up. That one there, solid angle. It's across the vertical. That one. This one. That one. Like so. Okay, just to have a general idea, let's go ahead and let's work with this right now. Let's go ahead and work with this and see what we get. An idea. This thing will not necessarily reach on the. So, okay, so as you can see here, this slotted angle thing fits across those magnets. Okay. So, let me just go ahead and pull this out. Did I scratch it? Nope. It's more or less the same. Okay. So this stuff would go across like so. Then we have like so. Actually goes across like this over these. And then pop this out over here. I have these over here. Let's hope this is the right one. Oh, okay, so actually this has to be over there. Okay. Or we can do it like this. We were saying earlier. sense. Okay, let's go ahead and put these screws on, just as an indicator. Oh, right. Let's see here. Here, like so. Oh yeah, because these would rotate as well. So we'll have our options. Might have to do some offset thing over here. Okay, now I got a better idea of what it requires. We'll probably have to get rid of 4 of the small ones here. These angles, I should be able to pull that off just fine. I have to do an angle like that, angle like that. That way, it gets pressed against the magnets, and I would tighten it accordingly. And then, what else? So rotate it like that, so it shouldn't bring into that. Oh, good. So, it's essentially what we would have there, and then the other being over here, be like the same way. This one is also the same way. So 4 down here. Now, I also have to keep in mind, actually we need these 2 over here. Now the purpose of this is to make it certain that this will be able to handle whatever G-forces that will be on these magnets as this thing rotates. Now this thing needs to be on the outside. So here. Okay. And this one over here. Let's go ahead and add some more on these ones. We need the extra thing. Let's not delay this anymore. Let's get this one into place. This needs to match properly. Let's go ahead and press that over here. Actually, you know what? This thing surely shouldn't be there. It should be over here. Put the small holes here against these small holes here. It makes more sense. Not in the inside, on the outside. Here. So the scissors are just thin enough to keep this nut flat as I turn it inside this hinge, so I should be able to turn this really rigidly. the same thing down here. Keep this square nut in place over here. And I'll adjust the angle of these later on. Tying it up and stuff later. Alright, so anyways, there's that one. The same thing on the other side. This stuff it goes a little bit further than I thought it would. So it's gonna be more like 3 1/4 inch in there, but it should be perfect fit inside that. And I'll just offset it a little bit on each side afterwards. Okay. Or you do like I originally had said, and simply adjust this one here as well as that one in order to create the necessary space. Whichever makes more sense. Can I do that or not? Nope, that's not going to happen. So I have to do it like this. Okay. And so, you do the same kind of deal on the other side as well. These over here. So 2, 3, 4, 5, 6. Yeah, we'll have plenty of to get this started. And 1, 2, 3, 4, 5, 6, 7, 5, 5, 6, 7, 7. So we got plenty. So after I make the magnet stack, let's see here. So the way this is going to be the cradle, and you see underneath there's this thing here, and this is 3 and a this is a 3 1/4 inch thereabouts inside. Now it's not exactly, so what I'm going to do, I'm going to rotate this a little bit to provide a horizontal restraint for that. Let's say, for example, in that one. Now you can see how I can just adjust that a little bit. So on the back side here. As you can see. So, I mean, the point is I can rotate these sides here just a little bit to provide horizontal constraints for this. So, all right, and there'll be vertical restraint as well. Ultimately, simply as a result of that. Where exactly do we put it? We got a total of 6 of these things. So what I could do, I mean, this is not really the issue. The point is to create horizontal restraint. That's the whole point of this, is to prevent the magnets from flying apart. Because they'll attract vertically just fine. It's just I need them horizontally constrained. So I've got a little thing here. Where I've got, here is 1 1/4 inches. 3 inches and 1/4. So that will fit over there, and I'll just have to offset these magnets accordingly in order to provide the correct spacing. Pretty much the same thing for these other ones later on. So I'm just going to go ahead and put these to the side here. Okay, gloves on. So I've got 2 hours and 8 minutes left on the clock. Let me adjust my hair. Double. Alright, so there's been 8 hours on the video already, so let's go ahead and try to finish this off. So YouTube only allows merger of video up to 6 hours. So, but whatever, right? Okay. Let's go ahead and do this. Alright, so first things first, we're going to get the first magnet here from there. Okay? So put this magnet over here. So let me go ahead and remove this magnet here. Let me pull it this way, away from the music stand. How's that? Right? So go ahead and separate it. Okay. So I'm going to have to hold this securely in some way. First of all, over there on this side here. Okay. So there's considerable friction on this magnet as I slide it over. Okay. So the next one is number 2, which goes underneath. So let's go ahead and do that. Oh, and another thing I will need to do. Oh, I know how to do this. So if I wanted to create the space underneath, all I have to do is move these panels sideways a little bit. So let's just do that right now. They're a half inch thick, so this will help me prevent having to turn this over all the time. It should be adequate. So let's go ahead and put number 2 underneath. We need to make sure this thing doesn't Oh, okay, that actually helps. Okay, so let's go ahead and put another 2 underneath. So let's go ahead and pull this out again. Alright. So, left hand over the side here, I'm going to enter at an angle over here. Now it's connected, it's held to the square nuts through their magnetic attraction. Now here's something I have to consider. Why did I get a magnetic pole detector? To make sure that I hook it up in the right direction. Because this is important, otherwise it might jerk on me unexpectedly. I know I had another one. There it is. Is it the right order or the wrong order? Wrong order, huh? Positives toward the spring. South. So this is south. Okay. And just for an extra bonus here, we've got our magnetic viewing film. And this only measures the transitions. It doesn't, let's see here. Alright, so let's go ahead and turn this around again. Alright. North turns to south. Okay, let's go ahead and zoom in. So there's one magnet and then there's the other. The transitions from north to south was represented by the highlighted region. If that's not close enough, let's zoom in even more. All right. Hopefully you can see that. Okay, so let's go ahead and put our gloves back on again. And we're going to complete the thing here for number 2. Alright, cool. So, let's turn around again. So number 2 will go to number 1, like so. That is actually a lot more sticky than I thought. That's good. I thought it was going to jump on me and everything. So there's that. Now, what I want to do is put another one. Number 3 goes across like so. So number 3. Oh dear, that's not good. Let's go ahead and remove this side. Make sure we can remove these properly. So let's go ahead and put this here. Turn this over. Okay. So now, again, north up on top, north here. So you're going to do an entrance from this direction and this way. So let's go ahead and turn this over here so we can. That was not what I intended. Okay, let's try this again. Alright. Okay, that's not what I wanted. So, we were having an issue here. You see those neodymium magnets really want to go that way, don't they? Let's look. Oh, we'll go look at the show coil again. Because I mean, these neodymium magnets all together. Should I do the stick one? I'm wondering if I should do the stick one. If I do the stick one, it's not going to work. It's going to have to be horizontal. So I'm going to have to separate this one out here. So let me put this one down here. And we have to do this correctly. So let's pull this out. Okay. And separate this out over here. So. I have to take this thing over here. So on the edge. Edge of the stand and then super strong stuff. Okay, let's go ahead and do this again. Not there. Far ends over here. Okay, we're really going out of sync here. Okay, let's try this again. There we go. Alright. So. Now, which side are we looking at here? It's got a nice chip now. That's cool. Let's put this chipped one over to the side. Take this one over here. Separate this one out. Alright, so we want a nice side on this one. South, north. So north is on top here. That's chipped on the corner. So this one goes over here. I want this one. We'll just make have the south facing up right now. So there's south. South. Okay. So next, what I want to do is I'm going to put the one down here. It's north, so south is over here. Okay, so the south goes underneath the other one, like so. I'm going to turn this away from me. Okay. I want to face this the other way, where it's not chipped on the outside. You know what? Let's go nope. Let's do it again. Nice. Really convenient. Oh dear. Right. So that's that one. What I'll need to do before I put number 3, I'm going to put number 4, because apparently it jumped out last time, so I don't want that problem to happen again. Of course, I put my hands too close to the thing, so that might be the reason. Alright. Not sure if the gloves are actually helping me. Okay. Now what it seems like is I now should take this thing and stick it out over here more and put another mat in there. Alright. Let's go ahead, you know, kind of doing this a little bit in a different order than I had anticipated, but it gives you an idea of what we should be doing. Okay. So let's go again here, and this stuff should be sticking in here. Oh, I put my glasses right next to the Neodymium magnets. That was smart, right? That would have been stupid if it actually attracted it. Alright, G was lucky. This thing needs to be held by rubber bands so it doesn't pop out. Alright, that's better. Okay. So let's do some more of this. Let's turn this upside down. Move these ones out here. Alright, so it's going to be on sideways here. Let's put this on the center floor here. You know what, we could put the bottom one on first, so that way it's flat. So let's go ahead and do that. South, south, south. Okay. So it's gotta be on that side. Here, essentially north, south. Okay. Let's do this again. Okay, so this magnet is way too attracted to this one, so it doesn't make sense to put that one there before I put the other one on the other side. So, alright, so that's stupid. Okay, do not rotate on me, please. No, it really, really, really wants to be that way, doesn't it? You know what? Maybe we'll change the shape a little bit. We could make it more cube-like, perhaps. Because it just really, really, really wants to change configuration on me. So I can make it 3 wide, and I could have these ones here stick out a little bit more. So 3 there, and then 2 that way. So maybe it just wants to do it that way. It's trying to change on me and everything, so we could, in fact, forego this gantry thing and make this just a little bit round. I had never thought of like that, so let's see here. It's going to be a little bit less thematism, but it's not going to stick out as far either, and we do need to, well, that one sticks out further. Actually, we could do this. So we'd really have a problem with this. We could do 3 that way, and then we could put those ones over there too. Kind of make it like a circle or something. Because it just really wants to be in a different configuration than what I had tried to do. So what we want to do is we want to put another side over on the other side, but we need to make sure it's pointed in the same direction. So let's go ahead and drag this over to this side here. Right? So the way this is going to be is just really wants to be on a different direction. Okay. North. Okay. So just really wants to be in a different direction. So let's go ahead and turn this around like so. It's going to about to snap onto my fingers if I don't do something right here. Let's go ahead and bridge this over here. The gloves are almost an impediment to the design. Oh dear, now it's sideways. Shit. Okay. Let's try this again. Do that, I need to make sure gloves on are tight as possible here. Okay, so let's go ahead and check again. North, okay. Sideways, okay, so sideways, alright. Now double check. So we can go ahead and push this up a little bit, bridge this up a little bit more. No, this way. I have to push this up a little bit more, then it will want to do that. Okay, obviously it's having some issue reconciling that. So what I'm going to do now is I'll put another one underneath there. As well, to kind of help this, go along. Nice. You know what? I'm gonna have to remove shit. This is really stupid. go ahead and turn this around like here. Sorry about that. Okay, this is useless. Okay, I'm gonna go ahead and okay, this way. Go. Music stands, gotta love it. Okay, so this goes here. And this one's here. Okay. Okay, now I got my fingers in between. This is turning a lot harder than I thought. Stupid freaking gloves. Alright. So stupid. Okay, at least I got that out. So let's go ahead and turn this one over here. Shoot. This is stupid. Shit. Stupid. Okay. Gee whiz. So hard. It used to be easy. I used to be able to do this stuff. So stupid. It's not gonna work that way. Okay. Yes. You know, I used to do a stick version. The stick version it seems to be easier to build. You know, what I should do. Okay, I can still make it a wider one. I just need to do it differently. You know, I have these two things here. You know what I could do with that? Instead of trying to separate them, which is ridiculous, I'm going to put this over somewhere else. Shit. Damn it. Oh my god. And if I bring it over there, it's going to snap the other way. Shit. Okay, I'm not going to do it with these two. What I need to do is put a supporting plate in between to prevent them from crossing over. So, Alright. So there it is right there. There's that. Over here, in the same deal, the other one. Wait a second, that's sideways. I don't like this sideways. Shit, pull this out directly out. If I pull it that way, then it's going to be like that. I'll push it down. Shit. Get ready for chaos. Glasses. Shit. Okay. How many hours we got? An hour 30 minutes. Okay, so this north is going to pop up over somewhere like over there, and I have to be very careful when this jumps. Okay. North. Good. Both north. Okay, awesome. Okay, so now really wants to do it that way, doesn't it? So that way. Okay. And so now I need this one. That's good Lord. Another one. I have to do a double. Great. How am I supposed to do this now? No, not that way. Not that way. Damn it. Shit. I'm wanting to do it that way. Shit. Why? It's the tractions versus. Let's just pull this out. That's what it's trying to do. It wants me to make it a stick. Oh, goodness. I did not expect it to be this hard. Pull this out. Okay. Then there. Okay. So we're gonna have to make it a stick. Goodness. It has no desire whatsoever to stick horizontally at all. At all. Okay. But I do have a plan for this one. Essentially, what we need the side flux is cut mainly through the far ends. That's one thing. Damn it. Okay, let's get the thinner magnets. So we can turn this around like this, like so, and then get some of the thinner magnets and just put them on over here. That's so stupid. Well, I can't. Seems like I'm gonna have to go back to my old show drive magnet stack layout. Alright, so that looks good. Okay, so same thing again on the other. Whatever. Can put another magnet here. And apparently the stick version is so much easier than the horizontal version. If it's repelling that way, it's going to be the other way. Please do not stop me. Alright, so there it is. Turn this around, like so, like that. Okay, you like it now? Alright. Okay. Okay, so obviously I'm going to have to turn this around more. I'm going to do that. Remove this one here, remove this one here. This around, so to take care of the other side. So I'm going to be doing the stick version here. Simply did not want to do it the way I tried to change it. So nice. Okay. 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 And then this one's the same way. Oh, goodness. So to heck with the horizontal, it's not even remotely stable. These magnets will not want to hold that configuration. There's no way I could clamp that with the way I had intended. So back to the old way. Okay. Alright, there we go. Okay. Oh, that's not exactly the right size. Right? So anyways, what I need to do really is I need to put another magnet on this side. I'm going to turn it like Jenga blocks. That is what we had originally intended. Oh dear, this is scary. Okay. I'm not familiar with this configuration. We have to figure this out real. Shit. Is there anything there? Damn. Yeah, of course. Okay. Sure. Let's go ahead and leave this thing alone. That's how. Okay. So. Okay. South. 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 Okay. So, okay. So what we have to do, put this on the bar. So, we'll drag it out here. Oh my god. Damn. Why can it not exist? Oh, and the other clamp. Shit. That's over here. And so, for that. Gracious. Okay. Put this stupid thumb. Alright. Okay. Alright, there we go. Okay. Right? So now, what I'm going to do is turn this over to here, Jenga style. Alright, this is the easier way to do it. That's, now, just need to, that indicates how much repulsion there is, like, seriously a lot. So now what we want to do is put it over here on this side here. Okay, this is stupid. You know what? Oh, gosh. So let's do that first. Let's see. We need to over here get one over here. One such thing. Shit. Sorry, that's a better number. That was easier to remove. Shit. So there it is right there. Now turn. Wait, before I do that, I need more of the small ones. Nope, nope, you're not going there. You're not going there. There we go. Right. Check the box. Seal it. Yeah, there we go. Seal it. Another one, just like that. Turn the other way. Turn this at some point. Slot in there, just like that. Turn. There we go. Check. Alright. Got it. We got the system now. This is more or less the shape I had originally planned. That I was more familiar with, and I tried to do a horizontal one, but apparently it doesn't want me to do that. So go ahead and finish it off. Okay. What are you doing? Nope, 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 nope. Okay, so there. That's one. Not on top of that. Not on top of it. Nope. Okay, check out. Shit. No. Apparently didn't want me to do that. Okay. Let's do some more. Nope, you're not going there. You're not going there. Alright, that's what I'm talking about. Alright. Another one. All right. Nope, you're not going there. You're not going there. Or are you? You're going to insist on it, huh? Damn it. Okay. Another one. let's see here. To do a significant redesign to the show coil in light of this technical difficulty, but I'll still be able to use what I just wound in order to do this. Let me go ahead and do one last thing here. You can see what happened on that one. It was crazy. So we've got one more that I want to do on the other ends, and then that's it. So for that, I'm going to separate this one over here, this one, and let's go ahead and just take care of that one, and then that will be our last piece. No more after that. A little bit disappointed in the assembly, but ultimately I should be able to figure out a modification, or maybe perhaps just go back to the original intended design for the show coil that set out initially. So, essentially, there we go. And really is not a perfect fit. It sucks. But the way to solve that is, shit, can't. Is it this? It seems like something like that. But I don't have any. I could do that. But then it would still be over that, and it wouldn't be flats. Anyways. Okay. Guess we're gonna have to settle for this thing. We need to keep this in a separate box. Okay, not near the computer. So we need to put this in a designated spot. It's real good. It's real fine design right there. At least one side is flat. It's because of the mat that's on the other side. Okay, that's probably what the reason is. Oh, right, because I hadn't put it there yet, of course. Or had I? That might be the reason. Or perhaps the reason why it's like that is because of that stuff on that side. So maybe what I should do is I simply remove this. That'd be a big deal. Or no. Oh, it's preferring what needs to be there, though. Have that one. So good. Space isn't there, duh. Good. That's what I wanted. You know what? Maybe I just need two more. At least it won't tilt, or I just have no reason to tilt. I mean, it's gotta stick there somehow. There we go. Maybe this will help. Okay, so most of the magnets are here. The rest is this stuff over here. I just need to keep this far and away from everything else that's magnetic. See this magnet, there it is. It's a stick magnet instead. Maybe this will be better after all. I mean, this is my original plan. So this is it's got 1, 2, 3, 4, 5 there, 1, 2, 3, 4, 5 on this side, and then 2 there, so 11. Each is ½ an inch thick. So this is 5. So 5 inches plus that's 6 inches long. So this is 6 inches long. I don't know if I should do another stack here to make it complete. I have a lot of the lines of flux come out of here, there, lines of flux come out there, short of that. So, I mean, this could still work for the show drive. It's just going to be my original geometry. It's about the same as what I ended up with, actually. So that hasn't changed much. And there is this looseness in the magnets, but this is not going to really cause any issues with that, is it? And in a way, I mean, it could demonstrate that there's no hidden batteries inside the stack. I mean, I could add more of, let's say when I remove this magnet, I screw this in here, I could slide it over, demonstrating that there's no hidden batteries inside the magnet stack, there's no connections. So maybe that's a blessing in disguise. Now, when this thing spins, it's going to be around like so. It's not going to be really focused on whatever. So go ahead and have a good idea of what this would look like. I think I should put this in the crate already, with the panel at least, to be more or less supported inside. Okay, so here's the other panel. Okay. Just to have a basic idea of what this will look like. Oh, okay. Yeah, just knock it over. I don't have all the rods in place yet, but this should work for the basic visual idea of what this will look like. So this one goes on that side there. This one will go over here, like so. Okay, I'm going to do this first, obviously, like I had originally thought of. This goes here. panels really like the bearings, apparently. Bearings liked by the show coils in there, they'll be kept separate. Okay. So, basically, wow, the magnet really likes those bearings. So, yeah, let's go ahead and take care of that later. Okay. So I'm gonna just leave it there. And later on, I will finish the curvature of the show coils, and yeah, hopefully this will actually work. Significant change in plans, but I think I have an idea of how I might just get it to work the way I had wanted. So yeah, I would like to thank you for your time, and I wish you a wonderful day. Oh, before I do that though, it's August 26th still, 10:34. Yeah. So there it is. I'll build the show coils and all that jazz. Have this finished at some point. Okay. Oh, and before I turn off the camera, I need to take some more pictures. Okay. Alright. Oh, this thing is supposed to be facing this way. Oh dear. Let's see. 6. Okay. Okay, so just to give you a general idea of what this looks like down here, let me go ahead and lower this for you. Alright, so you can see what that looks like inside. And have it inside here rotating. Of course, I'll have the plates held apart with the coils here. The coils over here, they'll be bent into the shape of an S. They'll be on the ceiling hooks. I'll get probably the more appropriate size ceiling hooks tomorrow for this. And over here, let's go ahead. See all this mess over here. Yeah, it's all messed up. Okay. What's the time again? There it is. All right, so it's 10:41 p.m. All right, so I'd like to thank you for your time. And anything else? I wish you a wonderful day. And just to show you that I really did originally want a stick-like magnet. That was the original plan that I had. Okay, so the mailing tube was meant for the spool and fasteners. Let's see, curved ruler, tubing bender, ceiling hooks, wood panels. We don't do wood panels anymore. We're doing acrylic. Ceiling hooks, bundle diameter. Okay, so alright, so that magnet stuff's in phase 2 actually. So magnetic rotor assembly. It was supposed to be 20 large neodymium magnets with dimensions of 3/2 inch by 3/4 inch by 1/2 inch. And they'll be stacked like Jenga blocks. Well, that's actually what I've ended up doing, even though I had a different plan. 8 small neodymium magnets, that's the stuff over here in the center to help space this. Together these will form a flush fit around a 3/2 inch by 1 inch by 1 inch yada yada square nut assembly, which is not exactly true because they're not exactly the size I wanted, but it's close enough. It's better, definitely better than what I had made years ago as far as the magnetic rotor. It's more symmetrical, it looks nicer, it has fewer chips on it, so this will definitely I need to of course put the show coils on the hooks, and I need to get proper size hooks, so I'll go to Lowe's tomorrow to get better hooks for my coils, which turned out to be bigger. I have more turns than I had thought, and so I'm going to be bending that into the shape of an S. It's going to probably be we'll add a little bit more there. I'm going to have it bowed out a little bit more, and it's going to be a sharp curvature at the ends, so that the lines of flux mainly cut through when the magnet's in the middle orientation. So basically, it's like what I said in that old video that I called magnetic induction 80s style. If you look for that video, magnetic induction 80s style, on the Show Drive's YouTube channel, then you should see pretty much the same explanation, which will be for this show drive. So most of the flux will cut through the ends of the show coils as opposed to the middle, like I had, recently had imagined. So this coil is going to be folded into the shape of an S, and I'm going to have another one just the same. And just to give you an idea how thick this is. Alright, so. And once I have it folded into a shape of an S, I'll have it some electrical tape around this. I'll stuff it into the ceiling hooks. And then doing that, I should be able to demonstrate the principle. Think of a new shape for this. First cut through there, then I'll affect that one more. Then let's other flex will line there, come back from there, and then the mesh will cut out through here. Shouldn't be too bad. bring us over there. It doesn't come back. So these ones over here return flux going the other way, and that would help with that. So until the end, it turn like that. Okay, so that should be good. You can see here, the rotor is indeed essentially flush with the panels here, if you can see that. Oh, you definitely weren't seeing that well earlier. Of course, the panels will be separate. Got some of that rubber glove there over here. It's a little stupid. I'll fix that later. If that matters, just poke it. Yeah, okay. Alright. Well, bye for now.